Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMathInstruction. Today, we're going to be doing Unit number 10, Lesson number 5, on Introduction to Rational Functions. So through the first 4 lessons of this unit, we've been concentrating on polynomials and polynomial graphs and their equations, and even in the last lesson on polynomial identities. Today, we kind of move on to a totally different portion of this unit, where we look at rational functions and rational expressions. So let's begin by trying to understand what they are. All right, it's pretty simple. A rational function, or a rational expression, is a ratio or a quotient or a division of 2 polynomials. So polynomials can generally be thought of like integers are thought of, I know that seems a little bit strange given how crazy polynomials are, but we looked back earlier in this earlier in this course and in Common Core Algebra 1, we looked at the similarities between polynomials and integers. Once we start dividing polynomials, like let's say this guy, we get a rational expression. So in the top we have a quadratic polynomial, in the bottom we have a linear polynomial. We could have a linear polynomial in the numerator and a cubic polynomial in the denominator, and those are functions, right? Because y equals, right? We have inputs, we have outputs. We could also just, take a look at rational expressions, right, where there's no equation. So in that one we have a cubic polynomial divided by a linear polynomial, and in this one we have a quadratic polynomial divided by a quartic polynomial. So obviously, throughout this, what we're going to be doing is we're going to be trying to understand rational functions and expressions, just like we understand fractions. Now, I know fractions are oftentimes not people's favorite, but throughout this, I'm going to try to keep drawing parallels between division and fractions and rational expressions, because to understand rational expressions and functions, you have to understand fraction work. But let's jump right into it. In exercise 1, it says, consider the rational function given by f of x equals x plus 6 divided by x minus 3. Letter A should be a piece of cake for us. It says, algebraically determine the y-intercept for this function. So pause the video now and go ahead and do that. That should be pretty quick. All right, well, this should be no problem. The y-intercept of every function is the output when x is equal to 0. In other words, simply f of 0. So that's 0 plus 6 divided by 0 minus 3. 6 divided by negative 3 gives me a y-intercept of negative 2. That's not so bad. Letter B, though, says algebraically determine the x-intercept of this function. And then it gives a hint. Hint, a fraction can only equal 0 if its numerator is 0. So think about this for a moment. All right, this is very, very important, not just the x-intercept, but to find the zeros or the x-intercepts of any function, we take the function and we set the y value equal to 0. But this is the first place when I really want you to try to understand fractions and use that understanding to understand rational functions. If I've got the division of 2 integers, like 8 divided by 4 gives me 2, or 3 divided by 6 gives me 1/2. The only way I can take 2 numbers and divide them and get 0 is if the numerator is equal to 0. So, to figure out the x-intercept here, I would just take the numerator, set it equal to 0, and that would be my x-intercept. Now, letter C. For what value of x is this function undefined? Why is it undefined at this value? Undefined, meaning that if we tried to put this value of x in and do the division, do the addition, subtraction, then the division, we'd go, yeah, I don't know. Think about that. This is very, very important for today's lesson. Well, it would be x equals 3. Now, why is the function undefined there? Well, let me show you. If I did f of 3, and I did 3 plus 6 divided by 3 minus 3, I'd get 9 divided by 0. But we cannot divide by 0, right? And of course, we can't divide by 0 because if 9 divided by 0 was equal to some, oops, sorry about that. If 9 divided by 0 was equal to some number, then 0 times that number would equal 9. Well, 0 times any number can't be equal to 9, right? I mean, 8 divided by 4 is equal to 2 because 8 is equal to 4 times 2. 3 divided by 6 is equal to 1/2 because 3 is equal to 1/2 times 6. But 9 divided by 0 can't be a number because then 0 times that number would be 9. But that just can't equal that. So this is undefined at x equals 3. But based on that, we can talk about the domain of this function. And the domain of this function then would be all values of x except x can't be equal to 3. That would be the domain of this function. All right? Pause the video now and think about every part of that problem. They're all quite important. All right, let me clear this out. Can't divide by 0, can't divide by 0, can't divide by 0, can't have 0 in the denominator. So let's try that. Exercise number 2. It says find all values of x for which the rational function h of x equals blank is undefined. Verify by using your calculator to evaluate this expression for these values. All right. So the whole idea here is that, if I take a number like 1 and I put it into this function, I'd get like 1 plus 5, and then I'd have like 2 times 1 squared plus 11 times 1 minus 6, and I'd get like 6 divided by 2 plus 11 minus 6, and that would give me 6 divided by 13 minus 6. I don't know why I'm talking like this. And then I'd have 6 divided by 7. Oh yeah, that's perfectly great. I mean, we may not love the number 6/7, but it's a number, right? But there's some values of x that if I put them in here, eventually I would, after doing all of this business, I would get a number divided by 0. And that is a problem. All right. So to figure out what those numbers are is as simple, or as difficult, depending on how you want to look at it, as taking the denominator, the thing that we're dividing by, and setting it equal to 0. Why don't you go ahead and try to solve that? Pause the video now. All right, well, you can solve that in a variety of ways. You could use the quadratic formula. You could use the completing the square, although I doubt anyone would be crazy enough to do that. Or in this case, we could use the zero product law. That's what I'm going to do. Now, the 2x and the 6 might throw you off, but remember, when I factor that 6, I can't put an even here, or this thing would have a GCF, right? So in fact, let's see, I got the 12 and the 1. That'll work as long as that's positive and that's negative, right? 12x minus 1x is 11x. This then will give me a factor of 1/2, and this will give me a factor of -6. So the function is undefined, has no value at those two. Now let's take a look at this for a moment, okay? I'm gonna show you something on the TI-84 Plus that's kind of cool. Let's open up the calculator. All right, there it is. I'm going to use the store command on this calculator to show how this function becomes undefined when the x value is -6. All right, so we could do the 1/2 as well. Maybe we should, I don't know. But I'm going to do the -6. So I'm going to do -6. I'm going to use this store button here, store in x. All right, now the calculator thinks that x is -6. And now I'm going to type in parentheses x plus 5 parentheses divided by parentheses, I got to have those parentheses in there, 2x squared plus 11x minus 6 parentheses. Okay, make sure it all looks right. Okay, and now I hit enter. And look what happens. It gives me an error. It literally gives me a division by 0 error. It says, hey, I can't do this calculation. Can't do it. Because for that value of x, you're forcing me to divide by 0, and that is mathematically impossible. There's never going to come a point, unlike square roots with negatives, There will never come a point when suddenly we're going to say, hey, actually, you can divide by 0. We've been lying to you this whole time. You can't divide by 0. It's one of the cardinal rules of mathematics. All right. Well, I'm going to put the calculator away for now. I don't need it anymore. Bye-bye, TI-84 Plus. Pause the video now and write down anything you need to. Okay, let me clear it out. I love storing the calculator. There's so many things on the graphing calculator that you can use to check your answers if you're just willing to do so. Don't forget that. They're very powerful machines. Let's move on. Let's see how much you understand this. Exercise number 3 says, which of the following represents the domain of this particular function? So, pause the video now and work on this. All right. Well, it says, which of the following represents the domain of this function? Well, a lot of functions have domains that are all real numbers. What's going to restrict this function are any values of x that make this equal to 0. Again, you could use the quadratic formula or the zero product law. I'm going to use the zero product law because it's pretty easy. Quadratic to factor. Factors as x minus 8 and x plus 2. And that's going to tell me that either one of these two values will make the function undefined. So the domain is all values of x such that x is not equal to -2 and 8. So choice 3. All right. Pause the video now and think about this for a moment. All right, let me clear out the text. And let's move on. Back side of the sheet. All right. So exercise 4 is more of a keeping skills up to date sort of thing, right? It gives me a linear function, and then it gives me a rational function, and asks me to find all of these function compositions. All right. So let's review how to do the first one, and then have you work on the other two on your own. What does this mean, f of g of -2? Well, it's pretty straightforward. It means we need to evaluate g of -2, which would be 3 times -2 minus 2. -6 minus 2 gives me -8. And then I have to put that -8 into f. So that would be 2 times -8 plus 1 divided by -8 plus 5. Right? What would that be? It would be -16 plus 1, then -3. That would be -15 divided by -3, and that would give me 5. So it's a function composition problem. Why don't you try letter B and even more challenging, letter C? Okay, let's go through them. Letter B is essentially identical in structure to letter A. So how does that play out? Well, first thing I'm doing is evaluating g of 2. So that's 3 times 2 minus 2. 6 minus 2 gives me 4. That's this guy. But then the 4 is what goes into f. So f of 4 is 2 times 4 plus 1 divided by 4 plus 5. That gives me 8 plus 1 divided by 9. That gives me 9 divided by 9. And that gives me an awesome answer, which is equal to 1. Now letter C, this is the most sort of abstract of them all, but we can still play it just like we did before. It's kind of like x goes into g, and what comes out is 3x minus 2. And now I have to evaluate f of 3x minus 2. Well, what does that mean? That means everywhere there's an x in f, I have to put in a 3x minus 2. So I get 2 times 3x minus 2 plus 1. And in the denominator, I have 3x minus 2 plus 5. Now I have to be careful here. Here I'll have a 6x minus 4 plus 1. And in the denominator, we'll have a 3x plus 3. So I'll get a 6x minus 3 divided by 3x plus 3. Now in later lessons, we'll learn how we can simplify that expression, that algebraic fraction, into more simple terms. But for now, we're going to just leave it that way, okay? Pause the video now. Copy down anything you need to. All right, let's clear out the text. That's gone. And now let's do something that it's been a really long time since we've done it. Exercise 5, again maintaining skills, says find formulas for the inverse of each of the following simple rational functions below. Recall that as a first step, switch the roles of x and y. So this is something that we're supposed to become mildly fluent with in Common Core Algebra 2, which is to find inverses of one-to-one functions. So each of these is a one-to-one rational function. Not all rational functions are one-to-one, but these two are. And whenever you're trying to find the inverse function, you simply switch the role of x and y, and then you solve for y. Now, in order to solve for y here, what we're going to do is classic cross-multiplying from middle school. We're going to multiply these together and these together. So we're going to have x times y minus 2 equals 1 times y. Let me just distribute that x through. That's going to be xy minus 2x is equal to y. Now, this is kind of tricky because you might feel like you've already solved for y given that it's over here, but it's also over here. So that doesn't work so well. And in fact, at this point, what I want you to do in these types of problems is everything that has a y in it, I want you to bring it to one side, and everything without a y in it, I want you to bring to the other side. Okay? Now, which side should you leave the y on? It doesn't really matter. If I bring the y over to this side, it will become a negative y. And if I bring this 2x to this side, it will become a positive 2x. Now, I'm still a little bit unclear about how to solve for y, but this is what we're going to do. We're going to take these expressions, and we're actually going to factor a y out. That's going to leave me with y times x minus 1 equals 2x. And then I'm going to divide both sides by x minus 1. So the inverse function is 2x divided by x minus 1. And that's fairly challenging. You know, it's quite a procedure to do that. What I'd like you to do is take your shot at it in letter B. Why don't you pause the video now and try to follow along what I did on letter A, but you do it for letter B. All right, let's go through it. Again, to find the inverse of this rational function, what I'm going to do is I'm going to take that y, replace it with an x, take that x and replace it with a y, take that x and replace it with a y. All right, I'm now going to cross multiply, and I'm going to get 2xy equals y plus 3. I'm going to move this y over to this side, and I'm going to just leave the 3 alone. I now can factor a y out of each of those, and then divide both sides by 2x minus 1. So I find that the inverse is 3 divided by 2x minus 1. And that's the inverse. So sometimes in Common Core Algebra 1, when we have things like inverses or function composition, we want to make sure that we revisit them with new types of functions that we introduce. And this is a good example of that. All right. I know that can be some tricky algebra there, but make sure to get good practice on it on the homework. Pause the video now and write down anything you might need to. All right, I'm going to clear out the text. All right, last question. Exercise 6. The function f of x equals x squared minus 8 divided by 4x is either an even or an odd function. Determine which it is and justify. Based on your answer, what type of symmetry must this function have? Use your calculator to sketch a graph to verify. All right, now this is kind of cool. Some functions are even, some functions are odd, and some functions are neither. But we're told in this case that this is either an even or an odd function, so the neither isn't even a choice. The question is, which one is it? So what I'd like you to do is I'd like you to try to figure that out. pause the video now and do whatever you need to do. You may have to look back in your notes to think about even and odd functions. You might have to look it up on the web. I guarantee if you type into Google even and odd function, it'll pull it up. So take a moment to try to work on this. All right, well, I hope you gave it your best shot. Even and odd functions are all about how functions treat opposite inputs. So if I put two values of x in that are opposite, what do the outputs look like? And you can really pick any two values of x you want as long as they're opposites of each other. What I went with were the values of x equals 4 and x equals negative 4. So let's take a look at those. Let's figure out f of 4. All right, so I'd have 4 squared minus 8 divided by 4 times 4. So that would be 16 minus 8 divided by 16, and that would be 8 divided by 16, which reduces nicely to 1/2. Let's take a look at f of negative 4. f of negative 4, I'd have negative 4 squared minus 8, sorry, that got a little messy there, divided by 4 times negative 4. Now negative 4 squared is again 16 minus 8. And in the denominator now I have a negative 16. So now I have 8 divided by negative 16, which is negative 1/2. Now take a look. What that showed me was that opposite inputs gave opposite outputs. And that means this is an odd function. All right. An even function would mean that opposite inputs gave me the same output. Now, what type of symmetry would it have? Remember, what type of symmetry do odd functions have? And that's symmetry about the origin. Symmetry about the origin, meaning that if I rotate 180 degrees about the origin, it will land on itself. So do this now. Pause the video now, use your calculator, put that function in, be careful about the way you put it in, use the window indicated on the axes, and sketch a graph to see that symmetry. I'll sketch it as well in just a moment. All right, so the function looks a little bit like this. Goes a little crazy as it approaches x equals 0 because it's undefined there. And then it kind of looks like that. Right? And you can kind of see that symmetry even though I've drawn it very poorly. If you took this thing and you rotated the entire graph 180 degrees about the origin, it would end up landing on itself. That's what it means to have symmetry about the origin, right? Which is kind of cool. All right, pause the video now, write down anything you need to, and then we'll wrap up the lesson. Okay, I'm going to clear out the text, and let's wrap it. So really, in this lesson, we actually reviewed quite a few things from previous portions of the course, all right, in the context of rational functions. And all a rational function is a polynomial divided by a polynomial. Now, because division is involved, that gets a little bit obnoxious because you end up sometimes having inputs that force you to divide by 0. And what that does is it changes the domain of the function from being all real numbers, i.e. throw in any value of x you want, to throw in any value of x you want except for these guys, because when you throw these in, they make the denominator equal to 0. We also reviewed, though, composition of functions, how to find inverses of functions, and also even and odd functions. All of these things you want to keep refreshing in your memory, and all of which will apply to various types of functions as we go through the course. All right. Well, I want to thank you for joining me for another Common Core Algebra 2 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.